Have you ever wondered how to deal with uncertainty when making decisions? What if there was a way to predict the future and make informed choices? Enter Monte Carlo simulations. These simulations are a sophisticated mathematical technique that involves generating multiple random values to estimate the probability of different outcomes in a system with inherent uncertainty. This technique is used across a myriad of fields, such as finance, physics, engineering, and business, to make decisions under uncertain conditions. The key principles of Monte Carlo simulation are random sampling, repetitive execution, and statistical analysis. Random sampling involves generating random numbers from known probability distributions to represent the uncertainty in the model's inputs. This is the cornerstone of the Monte Carlo simulation. Repetitive execution allows the model to explore a wider range of possible outcomes. The simulation runs repeatedly, using a different set of random numbers each time. Statistical analysis comes into play once the simulation results are in. The data is scrutinized to understand the distribution of outcomes and the likelihood of different events occurring. Output: Monte Carlo simulation has a vast range of applications. It's used in financial modeling to assess the risk and return of investment portfolios, evaluate stock options, and simulate market conditions. Engineers use it to analyze the stress and deformation of structures, optimize designs for material usage and cost, and simulate the behavior of complex systems. It's also a powerful tool in scientific research and business operations. The process of conducting a Monte Carlo simulation involves 5 key steps. First, define the problem and model. Identify the problem or decision to be addressed and construct a mathematical model representing the relevant factors and their relationships. Next, identify uncertain inputs. Determine the variables that have inherent uncertainty and assign probability distributions to represent their possible values. Then generate random samples. Produce a large number of random samples from the assigned probability distributions for the uncertain inputs. After this, run the simulation. Use the generated random samples to run the model multiple times, calculating the outcome of each simulation run. Finally, analyze the results. Summarize the simulation results statistically, identifying the distribution of outcomes, the likelihood of different events, and the sensitivity of the model to changes in input parameters. In conclusion, Monte Carlo simulation is a powerful tool for dealing with uncertainty and making informed decisions in complex systems. Its versatility and adaptability make it a valuable technique for a wide range of applications across various fields. So the next time uncertainty looms, remember there's a mathematical technique ready to help navigate those murky waters.